Hello, my dear friends. I welcome you to the Confused Physicist. Let's get confused together. Many of my audience members who have been through the elementary books of physics, they have seen the topics like classical mechanics, electrodynamics, calculus, algebras, differential equations. There are a lot more. We will get into them, but in the later videos. First, I thought, why don't I give you a classical way of thinking? So let's get started. To all my viewers, please mark my words very carefully because the flow of the logic depends on them. Here I have an object. What did I say? I have an object. I have a single object. Well, object. And I will call this object is in its original condition. Very good. Now I will make certain assumptions about this object. What are those assumptions? Let's see. Assumptions. I can measure some things about this object accurately at the same time. Well, what are the assumptions? This accuracy part and the simultaneity part. Very good. Now I will call these some things as initial conditions. Initial conditions. Very good. So these are the relevant initial conditions that I require to solve the problem. So now I will perform an experiment on this object and I will assume that I know how this object will react with that experiment. Now, why did I say I assume? There's a logic behind that because this assumption is based on multiple other assumptions, like I will assume that I have identical copies of this object, or I have certain means to create identical copies of this object, and I will perform this experiment in the same way on each of the copies, and every time they will produce me unique results. Let me write them down. Unique results. Okay. But we can do the experiment, or we can do this a little bit different way. Like I have this object and I am performing this experiment multiple times on this object in the same way, and I am getting unique results every time. Okay. So this unique or certainty about the results means a lot. That means that if I perform this experiment 99 amount of times, I know what will happen in the 100th time. Okay, and I will call the way this object is reacting with this experiment then rules. Like an apple hanging from the tree, if it gets loose, the gravity will pull it down. It's easy, right? So those are the rules. Now, if I know all the relevant initial conditions and all the relevant rules, I can predict the final condition of this object. Final condition with certainty and accuracy. The certainty things is very much important. Okay. So what did I learn? That if I know all the initial conditions and all the relevant rules, then I can predict. Well, and I can predict it without further measuring it. I don't need too much because I trust the past. As past has shown me so many results, and I will go with it. Okay. So this is the thing. Please mark it very well that without even measurement, I can predict the final condition of the object. Very well done. Now, I will take this blueprint and I will do another experiment. Okay. So let's see. Now, suppose I have a dice. This is a dice. I took the dice and measured the top face to be 1. Very good. So the initial condition is 1. And I will do an experiment, that is rolling the dice. After I roll it, I get a 6. Well. So what's the rule over here? If I have 1, then I will get a 6, right? Because I am following the previous blueprint, and if I follow that, if I have 1, I have a 6. Well, so I am taking this dice because it is its own identical copy, and I will do the experiment once again. I roll it again. Unfortunately, this time I am getting a 3. What happened to that certainty? This dice is a single object. Still, I'm following the blueprint, and it is not helping me predict the things. Remember, what did I say? That I have to know all the relevant initial conditions and the rules for accurate and certain prediction, right? Let me ask you, do I know all the rules and all the initial conditions? I don't think so. I don't know. While I rolled 1 and I got 6, the way I rolled the dice, the torque I generated, the air resistant it faced, and there are a lot more, like what was the friction of the table where it landed. There are lots more we ignored. There were many information here, but we ignored. That's why we are not getting a certain result, but we are getting something. Please notice this dice is a single object, but it is comprised of 6 equally probable faces. Let me write it down. Equally probable. Well, now this thing is coming. Yes or no? We are doing the experiment with the faces of the dice, and that's why, not only that's why, because I have multiple faces, but because of our ignorance, I am losing many of the information. I am getting probability, right? What's the probability? Probability is the number of desired outcomes out of the number of equally probable outcomes. So what is the probability of getting a 6? It should be 1 by 6, because there are 6 equally probable faces, and out of them I will get 6 ones. Okay. Now, my dear audience, there's something, there's a hidden rule inside this. Can you spot it? I have written over here equally. Do you see that when I say what's the probability of getting a 6, I can easily tell that it's 1 by 6. But if I ask you what's the probability of getting a 2, you will still say it's a 1 by 6. The probabilities are same. Why? Because this dice is a symmetrical object. I mean, it's a cube and it should be symmetrical. Symmetry is helping me predict the probability easily, right? Very good. So let me summarize. What did we learn till now? If I have the relevant initial conditions, let me write it down. Relevant initial conditions and rules. If I have them sufficient enough for the problem, then the things are predictable with certainty. Okay. Now, if the rules are not sufficient, they are not sufficient, I am getting probability. Yes or no? So how can I make things predictable? It's very easy. I will feed in some more information into our problem, more information that we ignored. Okay, good. So, to all my dear audience who are preparing for some entrance exams, there are many. So this is the basic formula for it. If you have the questions, spot the relevant initial conditions, write them down, spot the rules, okay, and identify the rules and just connect which formula I can use, and you will be able to predict the result with certainty. Okay, very good. So this is the very simple blueprint for classical thinking. Now I will go deeper into something. Let's see, I will do another sort of experiment. Let's see, is it the absolute way or something magical or weird can happen to us or the reality? Remember, I told you that I can measure some things about the object simultaneously, accurately. Well, we know that in classical problems we often deal with point particles. And in this experiment, I will be using a point particle, that is an electron. Very good. I have an electron and I have measured its velocity with 100% accuracy. This is the electron, this is moving, and I know the velocity. So, velocity measured accurately. I will say 100%. Okay, 100%. Okay. Now I want to measure at the same time where the position of where is the position of this particle. To measure it, I have to observe it from here. I have to measure the position from here, and from here, of course, I am using an instrument to measure it. I have to shower a light over it, right? Very well. Then the light is coming, and hitting the electron. The moment light hits the electron, it is hitting somewhere else. It is jumping off to somewhere else. So if I know the velocity accurately, I cannot figure out the position. Yep. So what happened to this simultaneity? The thing is, the problem is with the scale of the objects. The electron is so small that a photon can knock it off. But I don't think a photon can knock off a truck or football. So be assured you can still follow the previous blueprint for the classical problems you are solving in your classes. Don't worry. But the reality is this. If I have measured something accurately about an object, I will not be able to measure the other thing at all. And this is not the complete picture though. We will learn about it later when we will understand quantum mechanics, or we will try to understand quantum mechanics, because quantum mechanics is very much weird. It's weird to me. It was weird to many people. So we will try to understand quantum mechanics. So don't take a burden that if you don't understand, don't take a burden. Be happy in your lives. Okay. But I will do the last experiment, and this will shock you. This will certainly shock you. I have a single cat. I have a single cat. This is number one. It may or may not be single. It's not like us. It's not studying physics. It may have a girlfriend or a beautiful wife. You don't know. Let it be. And here I have a black box. This is the instrument for this experiment. And in this black box, I have a bottle of poison, right? Now, I put the cat inside the black box. What are the rules? The rules are that if the cat drinks the poison, it is dead. If it does not drink the poison, it's alive. Okay, pretty good. Now, if I close this black box, okay, and such that I cannot see what's happening inside the black box, for me, this cat is both dead and alive. Not biologically though. It's not a zombie. It has not taken physics till now. So it's both dead and alive. Analytically, it means that it's 50% possible that the cat is dead and 50% possible that the cat is alive. And I will call this to be a superimposed state. Superimposed. Let me write it down. Cluttery over here. Superimposed state. So what did we learn? That if I have all the relevant initial conditions and the rules, the thing should be predictable. But the shock to us is that for this cat, I am getting the cat can be, it's equally probable the cat is dead and alive, right? So even with all the relevant initial conditions, I am getting probability. Well, let's see what happens if I open the box and see what's inside, like measuring it. I can see the cat is either dead or alive. So the act of measurement is making the superimposed state to jump into one of the equally probable states, right? Very good. But the problem is over here. Despite of knowing everything, probability is coming. Well guys, the problem comes that there is no proper classical analogy to describe this. That's why a different form of methods and thinking processes were developed. Those were known as quantum mechanics. It's still so popular. Okay, but don't worry, things are not this complicated for the exams. You can still follow the previous blueprint. That will help you a lot. But I should say that this is the limitation of the classical thinking. Okay. Thank you guys for watching this video. Please drop a like and comment down below. Those will motivate me a lot to produce more videos like this. And please subscribe to this channel right now. Please subscribe. Okay. Thank you. Goodbye. This is Anubhav Datta and I am signing off.